In a previous video, we've learned about the concept of density. In that video, you learned that the density of any object or any substance is equal to the mass of that object or substance. So let's say we take some mass of any substance, we take its mass and divide that mass by the volume of that substance, and what we get is the density of that substance. So the density of most substances, mostly solids and liquids, is almost constant at a given temperature and pressure. So what do I mean by that? Well, if you have to get the basic idea of density simply means if I take a cube that has the dimensions of 1 meter by 1 meter, so all the sides are of 1 meter length. So this is 1 meter, this is 1 meter, and this is 1 meter. If I take such a cube, let's say of iron, what would the mass of such a cube be? Because the volume of such a cube is 1 by 1 by 1, which is 1 meter cube. So the volume of such a cube would be 1 meter cube, and if we divide anything by 1, we simply get the same number. So now the density of such a cube would be its mass, right? So the simple meaning of density is how massive such a block of 1 meter cube be. So if we take 1 meter, so if we take a block of 1 meter by 1 meter by 1 meter of iron, and let's say on the other hand I take a similar block, but let's say that is made up of ice. So it is very clear, we can clearly imagine that the block made up of iron, and here I have ice, let's say. So it's very clear that the block made up of iron would be more massive, more heavier, because weight is also something that represents mass, right? The more the mass, the more the weight of that object. So we can say that if it is very easy to understand that the mass of iron would be much more than the mass of ice if the blocks are of the same dimensions, 1 meter cube each. So that makes sense, and that is due to the density of the two objects. So iron is more dense as compared to ice, and similarly you can have various blocks and you can compare the densities of various objects. So that is the idea of density. Generally, if we look at the density of iron, so if we have such a block, the mass of such a block would be in thousands, right? So if we have, let's say, water, let's say here at room temperature, it's so if we take a container that has the dimensions of 1 meter by 1 meter by 1 meter, so if you have a tank that has a volume of 1 meter cube, the mass of water inside that container would be around 1,000 kilograms. So we have 1,000 kilograms of mass of water, and the volume is 1 meter cube. So that is simply equal to 1,000 kg meter cube minus 3. So what we see is that the density of water is 1,000 kg meter cube. Similarly, we can look at the density of other metals. Let's say we have some metal here. This is some metal A, for example. And let's say if I measure the mass of this block, the mass comes out to be 13,000 kgs, and again the volume is 1 meter cube. So if I have to find the density of this block, I would get 13,000 kg divided by 1 meter cube, and that should be equal to, well, 13,000 kg per meter cube, right? So now it is very clear that the density of this metal A block, so this metal A is 13,000, and the density of water is 1,000 kilograms. But the problem here is that dealing with such large numbers, 13,000, 1,000, so it's not so easy to deal with such large numbers. And to make matters easier, we come up with a new concept of relative density. What is relative density? Well, we see that how much dense is any object, let's say metal A, any substance, as compared to water. So it is clear that let me just remove all of this. So we just now saw that the density of metal A, some substance, was 13,000 kg per meter cube, and on the other hand the density of water was 1000 kg per meter cube. Yeah, and it is very clear that this is 1000, this is 13,000. So the density of metal A is 13 times higher, or it is 13 times the density of water. So the density of water is 1000 and the density of metal A is 13 times larger, 13 times more, or it is 13 times the density of water, which means 1000 into 13,000 kg meter per cube. So this number here 13, this tells us how many times higher is the density of any object as compared to water. Now we can use this concept of a relative density to write the density of various objects. So what you can see is that we can say that the relative density of metal A is 13 as compared to water. What does that mean? Well, it says that because the relative density of metal A is 13 as compared to water, or with respect to water, it means that metal A is 13 times, so the density of metal A is 13 times more than the density of water. So we can similarly find out the relative densities of various other substances. And if we have to generalize, what we did here was we took the density of the given material, which is 13,000 kg per meter cube, divided that with the density of water, which is 1000 kg per meter cube. If we divide this, what we are left with is 13, and also see that the units cancel out perfectly. So we are left with no units, and so that means that the relative density of any substance is a unitless quantity. It has no units because it only tells us how many times something is more than some other thing. So it is just simply a ratio of two quantities and it has no units. So if you have to come up with a general formula for relative density, we may come up with this. We may say that the relative density of any substance is equal to the density of that substance, also known as the absolute density. Let's just call it simple density. So it is equal to the density of that object or that substance divided by the density of water. So that is a simple formula we get. The relative density of any substance is equal to the density of that substance divided by the density of water. So here generally we take relative density with respect to water, or in comparison to water, because water is one of the most prominent, one of the most abundant substances that we have around us. So we have oceans, we have we have a lot of water bodies around us, and therefore using the density of water as the reference, or finding the relative density with respect to water, is a useful quantity. Also, we would see in the coming videos why the relative density of any object with respect to water is a very useful quantity. Is a very useful quantity when we discuss about objects that are immersed in water or put in water. So that's it for this video. I hope you understood the concept of relative density.